Hi, my name is Alex. In this video I'll show you my electric heat exchange recirculating mash brewing system. I'll take you through each of the different kettles, the hot liquor tun, the mash tun, the boil kettle, as well as going over the electronics, the control system that I have designed and built myself. So, enjoy. Okay, we'll start off the video by taking a look at the three different kettles that we have here. On the left, there is the hot liquor tun. It's basically a hot water tank. In the center, there's the mash tun, and on the right hand side, there is the boil kettle. So we'll start off by taking a look at the hot liquor tun. All three kegs have been polished to a mirror finish. They also have a 12-inch hole cut in the top that perfectly fits a 12-inch stock pot lid. Taking a look inside of the hot liquor tun, you can see that there's a 25-foot copper heat exchanging coil. Down at the bottom there's a 4,500 watt heating coil from a hot water heater, and then there's a center dip tube. In the back, there's also a PT100 thermocouple mounted through the wall. Taking a look out front, we have a port for a top whirlpool arm, which is right there. That's for filling and recirculating water. There's a level tube on the side with markings up to 15 gallons. Down here at the bottom, there is the adapter for the center dip tube. And then up here, we have the input for the heat exchanging coil and the output. On the side we have a junction box with an LED mounted on it that connects to the heating coil. The LED displays whether or not the heating element is firing and is very easy to see based on looking at the pot. Around back we have a PT100 thermocouple, and that's mounted on a half coupler, and everything you see is stainless steel. All the couplers were soldered in with silver solder by, it's Harris Plumbing silver solder. I dimpled all the holes in order to maximize the surface area that the solder would come in contact with the coupler. So moving on to the mash tun, if you take a look inside, down at the bottom, you have the false bottom with a hinge in the middle. It's currently folded over so that you can see the difference with and without. There's a dip tube that goes down in a hole in the false bottom, and then the orange and black part is a lock line sparge arm that can be positioned in any way to fit different grain bills. Coming out front, we have the top here goes into the sparge arm. This is the input. The thermocouple is actually mounted in the intake stream, so the water going into the mash tun during the recirculation step is what's actually being controlled by the PIDs, and we'll get to that later. And then down here is the that's the false bottom dip tube that you saw inside. And then the final kettle we have here is the boil kettle. This is a pretty simple one. We have the PT100 thermocouple mounted in the back, another 4,500 watt heating element with a dip tube mounted off to the side. And you'll notice that it's mounted off to the side because the whirlpool arm here, which is mounted at about the 4-gallon mark, spins the boiled wort around in a circle effectively causing a cone of hops in the middle, eliminating the need for filtering or a hop back or anything. And then, as with the hot liquor ton, there's a junction box with an LED on the side. And then we have another level tube here, and the whirlpool input and the dip tube output. And then again, around back is another PT100 thermocouple. And that's basically it for the kettles. I've also created a little pump caddy with 2 stainless steel inline chugger pumps. I've put a purge valve on each one on the intake side to purge out any additional air, because magnetic chugger pumps are not run dry and need to be purged. And then I have a valve on the output for changing the flow rate. And here is the control panel that I have designed and built. If you notice, we're actually in my laundry room. It's the only room in the house that has 240 volt AC. We're moving into another house, and I hope to be able to put a spa panel in the basement and have a dedicated area for brewing. But for now, this works fine. So up at the top, we have the 240 volt in. We have the hot liquor ton element connection, which is rated to 30 amps. The boil element connection, which is also rated to 30 amps. A power control for pump 1 and pump 2. And then the 3 PT100 temperature sensor inputs. Around the front, we have the main power switch here. A volt and amp meter, which actively displays the voltage and the amperage that the panel is pulling. Emergency stop button, functions exactly as you would imagine. The alarm, which is both visual and audio. A switch for the element power, that without this being on, basically no power is possible to come out of the elements. So it's kind of like a safety switch, so that you can have the box on and still see the temperature readings, but have no possibility of the elements firing. Below them, you have the selector switches for the alarms. Each PID can be programmed with an upper and a lower limit alarm, and this basically allows the buzzer to sound. Below that, you have a selector here which selects either the hot liquor ton or the mash PID. And then farther down you have the element selector, which selects the hot liquor ton element or the boil element, as well as corresponding LEDs to show whether or not the element is currently firing. You also have the pump switches. So let's fire this up and take a look. So I'll turn on the main power here. See the PIDs start up, showing that they're set to Fahrenheit and PT100 status. So obviously there's nothing in it, so these are all reading ambient, so about 70 degrees in here. If we go ahead and turn the element power on, you can see that the light lights up, but none of these corresponding lights down here light up. So for the first step, what you're going to do is you're going to want to select the hot liquor ton. And it's important to note that nothing's plugged into this right now, so there's no possibility of running these elements dry. So you select the hot liquor ton, and then the hot liquor ton PID. And the yellow light here illuminates, indicating that this hot liquor ton PID is currently controlling the output of the system. After the first step, when the mash starts, you flip this over to the mash. Again, this yellow LED lights up, signifying that the mash PID is currently controlling the output. Once the mash is complete, we switch it over to the boil, and the final LED turns on. It's important to note that the first 2 PIDs are MyPins, which is a Chinese company. I found these off of Newegg, and they're far less expensive than the Auber. But the Auber has the added functionality of being able to do pulse width modulation, which is very handy for the boil, because if you have the 4500 watt element on at 100%, it's going to be too much of a rolling boil. So I found that the optimum level for a 5-gallon batch is about an 80% duty cycle. And then if you look down here, we have the different pump switches. Those are basically just switch power plugs for the pump caddy that I showed you earlier. And then of course the emergency stop button up there, which sounds the alarm. And that's basically it for the control panel. Taking a look inside the control panel, you can see all the wiring that I've done. You've got the 3 PIDs here, and the panel is currently unplugged, so this is safe to touch them. You've got the 3 PIDs here, the emergency stop switch, the meter is right up here, the power switch and power indicator right there, the buzzer, the 3 alarm switches here. You've got the indicator switches, or the indicator LEDs here, here, and here for which PID is selected, the PID selector switch, the element selector switch, the 2 element LEDs, and the 2 pump circuits are right there. Going over to the other side, we've got the port plate back here, so that's input, hot liquor ton element, oil element, pumps, and then the 3 temperature controllers, which are 3-pole XLR plugs. Got the hot side distribution and the neutral side distribution blocks. We also have 3 mechanical relays here. We use mechanical relays for the main power into the box and selecting the different elements. Mechanical relays can be used in this situation because they're switched as opposed to through the PID. And then here you have the 2 SSRs, which are also my pins and are fired by the PID controllers. It's required that you use SSRs for the PID control because a mechanical relay, while it could do it, would be switching so fast that you have the possibility of welding the terminals, whereas a SSR is designed basically to do that. Underneath of the SSRs, because they're switching so quickly, we have 2 heat exchangers set up underneath, and they're connected to the SSRs with some thermal grease. There's also a little fan down there to recirculate the air within the box. Alright, so this is basically the first step of the brewing process. We have 13 gallons of water in the hot liquor ton over here, heating up. You can see the water there, and I've got it recirculating through the pump, so you can see it coming out of the whirlpool adapter up there. It comes out of the bottom dip tube, goes through the pipes down into the bottom pump, out and then back up in, just to circulate it and have an even temperature gradient throughout the entire pot. So over here, we are on the first PID here for the hot liquor ton. We have the set value is 168 degrees, and currently we're sitting at 152. So we've got the element power on, and the hot liquor ton element is currently firing because the LED is on. I've also added an LED over on the pot so that you can see just by looking at the pot whether or not it's firing the element to prevent a burnout. Looks like currently we've got 235 volts and 18.8 amps pulling out of the system, and that's with the 1 pump running and the hot liquor ton element. Okay, so now we're going to grind the grain to put in the mash tun. So this is what we're starting with. We've got whole grains and a little bit of flaked oats in there. Once it goes through the grinder, the mill, it's a 3-roller monster mill, it's going to come out looking like that. So it's nice and crushed. Holes are pretty intact because it's the 3-roller version. So we're just going to go ahead and grain the rest of the 10 pounds. It's all finished heating up in the hot liquor ton. You've got 10 pounds of nice milled grain right here. And we've got the false bottom installed in the mash tun, which is the center pot. So now we're going to dump it in, install the lock line sparge arm, and I'll show you guys what that looks like. Okay, so we have our grain in the mash tun with the sparge arm all set up. We've got 13 gallons of water in the hot liquor ton sitting at 166 degrees. Our target for the mash temperature is 152 degrees. The reason we're striking at a higher temperature is to overcome the thermal mass of the grain that's sitting at room temperature. So we're going to go ahead and add about 4.5 gallons of water. Okay, at this point it's about 10 minutes into the mash. You can see the center mash PID is currently selected. The yellow light indicates that this mash PID is selected and is currently controlling the system. Set to 152 degrees. It's currently sitting at 151, and you can see the hot liquor ton element is blinking, which is the PID trying to raise the temperature 1 degree without overshooting. And again, you can see the status indicator light on the side of the hot liquor ton is also blinking, indicating that the element is firing. Now it's important to note that for the mash, the temperature is being read right here on the inlet of the mash tun. So after it goes through the heat exchanger coil in the hot liquor ton and pumps into the mash tun, it is being introduced back into the mash at exactly the correct temperature. You can see the foam has started to come down, and it's a little bit hazy right now because it's only 10 minutes into the mash, but that should change by the end. So we're currently in the sparge step. We have water from the hot liquor ton over here at 168 degrees, pumping into the top of the mash tun right there. And then coming out of the bottom of the mash tun here, we have the wort, which is being slowly pumped into the boil kettle over there. So I'll show you right here, it's just kind of trickling out ever so slowly. We've got fresh water coming in there at the top through the sparge arm. And we've got the 2 pumps right there running the whole thing as it's set up. Okay, so we've collected about 7¼ gallons of wort. It's now boiling. We've got an ounce of Tettnang hops we're going to add in. And we're going to start the timer. Boil for an hour. Now it's time to cool it down. Alright, at this point the boil is finished. Add a late addition of some orange peels, so that's what that is down in there. We are now pumping the boiling wort, the hot wort, through the pump, through the heat exchanger coil of the hot liquor ton, which is now filled with ice water. This ice water is used to cool down the hot wort as fast as possible. So it's been about 5 minutes running through this, and we're at 138 degrees right now. You see I got a little adapter bringing cold water from the sink into the ice water. So after we cool it, we're going to pump it into the bucket and aerate it at the same time, add the yeast, and then we're done. Okay, with the wort sufficiently cooled down, it's now time to pump it into the fermenting bucket. Pump it through the heat exchanging coil one last time to get it a little bit cooler. The full pot right now is sitting at about 100 degrees, so it should be pumping through at about 70 to 80 out of the tube. So it's very important when transferring to add enough oxygen into the wort so that the yeast has enough oxygen and nutrients to live, so that the fermentation is nice and vigorous. So what I've done is drilled some small holes into this plastic tube, and I'm using the Venturi effect to pull air into the stream as it's flowing by with no added equipment. So basically I'm just pumping it through this tube that's got these little holes in it. Okay, so I have transferred the entire batch into the fermentation bucket and added the yeast. And now you see that I've got a blow-off tube going into a jar filled with some star sand. I made a temperature controller out of an STC 1000, which has a thermocouple built into it. You set it for a temperature in Celsius that you'd like it to hold, and it controls a cooling and a heating circuit. So if you notice, this is inside of a refrigerator, which is set to the coldest setting, so that when the STC 1000 tells it to turn on, gives it power, it will automatically start cooling. I also found this neat little 150 watt MyHeat heater, and I cracked it open and added a separate wire for the fan and the heating circuit, so that I can have the fan plugged in continuously to the fan circuit, and then the heat basically just turns that heating element on and off, and it keeps a very accurate temperature in there within a degree. So I have also made a little stir plate out of a hard drive magnet and a couple of 40mm fans in a Rubbermaid container. I hot glued all that together with a potentiometer, and I got a stir bar off of Amazon so I can make yeast starters also. So that's pretty much it.